Hi, welcome to EcademicTube. The topic for discussion is the maximum likelihood estimator for a normally distributed population, where the probability density function of normal distribution is defined as 1 by sigma under root 2 pi e raised to power minus half x minus mu square divided by sigma square, where mu and sigma are the population mean and variances respectively. So we have to find out the maximum likelihood estimator in the two conditions when population variance is known and when population mean is known. When population variance is known, then we have to find out the MLE for the population mean. And when population mean is known, we have to find out the MLE for the population variance. So now we will find them by one. So let mu and sigma are the population mean and standard deviation respectively, and both are from the normal population. Means to say the random variable x follows the normal distribution with mean mu and variance sigma square. Then their distribution function is defined as x minus mu square divided by sigma square. In first case, we have to find out the distribution function of sorry maximum likelihood estimator of population mean when variance is known. So first of all, we have to derive the maximum likelihood function for the density function fx mu. So likelihood estimate of will be I raised to power 1 to n f of xi mu sigma, that is equal to product over 1 to n 1 by root 2 pi sigma. So here likelihood function will be equal to 1 by sigma root 2 pi raised to power n exponential minus 1 by 2 sigma square summation over I is equal to 1 to n xi minus mu ka mu raised to square. It is known that the maximum likelihood estimate for L and log L both are the same. So for the uh, solving purpose, we will take the log L of the maximum likelihood estimate, that will be equal to minus n log under root 2 pi minus n by 2 log sigma square minus 1 by 2 sigma square summation over x minus mu का mu raised to power. We have in first case we have to find out the maximum likelihood estimate for the mean. So we will differentiate log L with respect to mu, that will, and we will put it again equal to 0, which gives minus 1 by 2 sigma square 2 over summation over xi minus mu, that is 0, summation, because sigma square cannot be 0, sigma square is always greater than and equal to 1, but this term can be equal to 0. So we will take summation xi minus mu will be equal to 0, which implies n mu is equal to summation xi and mu cap is equal to summation xi divided by n, which is equal to x bar. So we can say that x bar is the maximum likelihood estimate for the population mean. Similarly, in second part, we have to find out the maximum likelihood estimate for the sigma square. So we will differentiate the log L with respect to sigma square. That will give it minus n times 2 sigma square plus 1 by 2 sigma square summation over I is equal to 1 to n xi minus mu raised to power square is equal to 0. That will give us sigma cap square is equal to 1 by n summation over I is equal to n xi minus mu का square, where mu is known. So it was the estimate for the population variance when mu is known, and in first part we find the estimate of population mean when population standard deviation is known. So this was the problem of maximum likelihood estimate. I hope you understand it very well. Thanks.